Yo, what's a dog's favorite superhero? Obviously, Labrador. Get it? Get it? Uh-huh. Okay. Let's talk about mean and variance of a continuous distribution. Now, we've found mean and variance for discrete distributions or discrete PDFs. Now we're going to find it for these continuous distributions that we're looking at, so the more specific ones. So I just want you to remember that your mean is your expected value, which for your PDFs is given by the sum of your x times your function. And so what I want you to note here is now the fast way is take a look at that. You can just integrate it, okay, in between your 2 points. And then you find it's just x times your function. That's going to give you your, what do you call it? That's going to find you your expected value. So that's kind of nice. And then so for your variance x, there's two main formulas. I've given you the formula that you get in your reference sheet, which is this guy here. I'm pretty sure you get both of them, but this is the one I prefer. And so for your variance x, what you've got here is you've got these two different formulas. You can do x squared fx, which is the one that I tend to use a lot. And then once you do all that, take away your average squared or your expected value, your mean. Or you can do this one here where you go your x, take away your expected value, brackets squared, multiplied by your fx dx. Okay, so with that in mind, there's your nice little formulas. And also just don't forget that your standard deviation is a square root of your variance, or your variance squared is your standard deviation, either one you want to remember. Now let's take a look at this question. We've got find expected value, variance, and standard deviation of this PDF y equals to 1 on 50x for values between 0 and 10. Now, we don't have to verify this one's a PDF. If they tell you it's a PDF, it's a PDF. So in terms of tackling this question, first things first, expected value. We know that your expected value should be fx dx, right, between 0 and 10. Now, in this particular case, our function is 1 on 50. So in other words, what I'm really integrating is between 0 and 10, 1 on 50, and then x times x, which gives me x squared. Okay, so essentially that's what all I'm doing to find my expected value. Yeah, so from here, let's clean this up, or let's integrate, raise 1 to the power. It's going to be x cubed on 150 between 0 and 10. Hopefully that's what you guys end up with, and then that ends up being I think 1000, because that's over 150, take away 0 on 150, which is just 0, and that will give you something like let's clean that up. How many 50s? Something over 3, 20 over 3. Okay, so that for this particular case, our expected value is 20 on 3, or in this case, it means 6 and 2/3. I'll write this down because I want you to make sense. That means my expected value between my scores between 0 and 10. That means I'm expected to get 6 and 2/3. Okay, now how do I find my variance? Okay, now my variance again is going to be between my two points here. And then the one I'm going to use is probably going to be this one here, the top one, because I prefer that one. It's going to be x squared times fx. So it's going to be x squared fx dx, take away mu squared, right? Because I've already found what mu is. So in this case here, it's just going to be between 0 and 10. And x squared fx is going to be x squared times 1 on 50. So it becomes 1 on 50 x cubed, right? dx, and then I just need to take away, in this case, 20 on 3 squared. Okay, and let's do this. So this becomes x4 over 200, I believe. And again, evaluating between 0 and 10. And this just becomes 10,000 over 200, take away 0. And that ends up just being, I believe, how many 200s go? How many 2s go into 100? It'll be 50. And then I need to take away my 20 on 3 squared. Take away 20 over 3 squared. So again, that was my integration, and then I'm taking away my average squared. And whatever that gives you, I believe that should end up becoming your let me just put that in the calculator. 50 take away 20 on 3 squared. I believe that should leave you with 50 on 9. Let me just double check that. Yeah, that's correct. So that becomes 50 on 9, and that's your variance of x. And so to take that further, how do I find my standard deviation? It's just going to be the square root of that. So it's going to be the square root of 50. Okay, and that just becomes your answer. I'm happy for you to simplify that, or to give it an actual number, or to simplify it, but that there is your general process. Hope that helps. I'll catch you in the next one. All right, bye.